Hi everyone, welcome back to the solid principles, and in today's video we will be talking about Liskov substitution principle. The term was coined by Barbara Liskov and the principle is named on her, and this was introduced in 1987. So this principle simply says that all the subclasses of a superclass should be able to implement all the methods written in the superclass without an error occurring. Okay, so let's try to understand this. I understand that definition is kind of confusing, and even if I put the exact term or exact definition written by Barbara, you'll not be able to understand it in the first attempt. Okay, so let's try to understand it with the help of a simple example. Normally I do not prefer these kind of examples where I'll have to use the superficial thing, but for the sake of simplicity we will be using it, and later on we will do some Salesforce generic example as well in our developer console. Okay, so let's say you have an animal superclass and it has a method roar. Okay, and it has couple of other methods like eat, like sleep. Okay, now this roar method is not relevant for all the types of animal. So let's say if a dog will be extending, or if a bear will be extending this. Okay, dogs don't roar but bears do, lions do. So in a way, a method written in a superclass which is animal is not relevant for all the animals. Let's say now we will be creating these subclasses and we'll be calling these methods. So let's say if we create one subclass for dog, then that subclass will not be able to use the roar method. Okay, so in that way a subclass is not able to implement something which is written in the superclass. That will be the violation of Liskov substitution principle. Liskov substitution principle simply says that if you have written couple of methods in main class or the superclass, all the child classes or all the subclasses which are going to implement or extend this class will have to will be should be able to use all the methods written in the superclass. Now because this roar method is not relevant for dog, the subclass related to the dog will not be able to implement this method, and that will be the violation of Liskov substitution principle. Okay, now let's try to understand this with the help of a Salesforce example. So let me go back and share my Salesforce screen, and then we will create a class. Okay, let's try to create a employee class, and let's call it a virtual class, and let's create a method public virtual void, and it has a method, let's say login. Okay, and there will be some logic for it like code to execute login method. Similarly, there'll be couple of more methods like let's say public virtual void timesheet method. Okay, and code to execute timesheet method. Now this is your superclass. Okay, let me put a comment here and say that this is the superclass. Now let's create couple of child classes. So I'm going to create one child class. Let's call it full-time employee, and full-time employee will extend the employee class, and then we will provide body for public override void and login method, and another one for the timesheet method. Okay, let's make sure that we have correct spelling everywhere. We can write anything over written code for login and over written code for time sheet. Okay, let's save this. Let's put a comment and say that this is our subclass 1. This is our subclass 1. Let's call it S1. Okay, now let's create another subclass and call it S2. This is going to be a part-time employee. Okay, now this will also extend the employee and the methods written in it. Okay, let's save this. Now let's call it, this is subclass 2. Now understand this, we have two subclasses, S1 and S2, and because S1 is a full-time employee, both the method login and timesheet, both the methods are relevant for full-time employee. Okay, so if I create the instance of this class and if I use the login method and timesheet method, I will be able to use both. Okay, so my subclass will be able to use both the methods which are written in my superclass. So in a way, my subclass is able to perform whatever it promised superclass to be able to perform, or whatever there was a handshake between the superclass and subclass, which says that superclass asks subclasses to make sure that you implement both the methods and use them. So Liskov substitution principle says that if your subclass is able to use both the method perfectly fine which were written in the superclass, then that's a valid scenario and your design is following the Liskov substitution principle. Okay, so far so good. How will we create it? We will create it like this. Let's say if I create the employee class instance emp1, and if I associate it with the full-time employee, new full-time employee, and let's say if I say emp dot login and emp1 dot time sheet, there will be no error. There will be no error because this is following the Liskov substitution principle. Now we have a part-time employee class. Okay, though we have not written any code in it, but the part-time employees or the contractors do not log in the system. So whatever written in this is not valid for them, and if you run it, it will throw a runtime exception. Okay, we are just assuming it, we are not running anything in it, but just assuming that login is not relevant for part-time employee because they do not have, let's say, the associated login ID generated to login or tag the login. So if we try to run the same code which runs for login for full-time employee, that will throw a runtime exception. Now because your subclass is not able to use the method written for login, it is not able to fully run the methods written in the class, and that is the violation of Liskov substitution, which says that your subclass should be able to run all the methods written in the superclass and should not change the behavior of it. So behavior of login method is that user should be able to log in. But because that behavior is not valid for part-time employee, even if we run the login method, that will give us the runtime exception that will change the behavior of the program. And as per Liskov substitution principle, behavior of program should not change, or we should not get any exception. It should run perfectly fine. So this is the case where the login method will not work for part-time employee, and your subclass will not be able to run all the methods written in the superclass. That will be the violation of Liskov substitution principle, and in that case we will have to rethink about the design. We'll have to rethink how we want to implement it, and definitely not by creating a virtual class and extending it. Maybe some other way, maybe creating different interfaces, one for part-time employee, one for full-time employee, or maybe have a different way to run this thing. But this design will not work as per the Liskov substitution principle. So that is what Liskov substitution principle says. If I try to run it, it will be like this: emp2, let's say new, and here it will be part-time employee, and it will be emp2 dot login. Even if I run it, this will throw a runtime exception and violate Liskov substitution principle. emp2 dot timesheet. Timesheet is still a valid method for even part-time employee, so this will run fine. But even if one method is giving exception, that will be enough for us to say that this design will fail, and this will be the violation of the Liskov substitution principle. Okay, so that's the summary of Liskov substitution principle. This is the most confusing among all the four principles, all the five principles, and I understand that there can be confusions, but feel free to ping me if in case you have any confusion in it, and I will try to take another example, or I'll try to set up some calls with you all to explain this even further. But make sure that you do not just mug it up. Try to understand it, and if you are not able to understand it, come back to me and tell me that there is some confusion in it, and I will I'll take some sessions, or I'll try to make it work for you. Okay, thank you. I'll meet you in the last solid principles later on. Thank you. Bye bye.